This video is about graph of a polynomial. Let's learn some terms for polynomial. For this n means degree of the polynomial f. The term a sub n x to the nth power is called the leading term. Leading term is very, very important because it decides the graph of a polynomial. The real number a sub n is called the leading coefficient. Then a sub 0 is called the constant term of a polynomial. Now let's talk about any behavior of a graph of a polynomial functions. We know the graph of a polynomial functions is decided by the leading term. We have a leading coefficient a sub n and also degree n. How to remember the n behavior of a graph of a polynomial functions? You need to remember some typical functions we already learned. For example, when n is an odd number, that means you have 1, 3, 5, keep going. When leading coefficient is a positive, everyone is so familiar with y equals x. For negative leading coefficient, just remember y equals negative x. For even degree, like 2, 4, 6, keep going. And when leading coefficient is a positive, think about y equals x squared. And when leading coefficient is a negative and degree is even, think about y equals negative x. Therefore, if degree is odd and leading coefficient is a positive, the graph like y equals x, graph like this. Between two arrows, we put dot, dot, dot. Maybe there is a lot of turning points, like this, going up and then is like this. And for y equals negative x, you know the graph like this one. Same thing. We put the dot between two arrows. The graph could be like this one. You have turning points like this. For degree, it's even and the leading coefficient is positive. We use y equals x squared. For y equals x squared, we know the graph like this. Still, we put a dot between these two arrows. Maybe the real graph is like this is the one. For y equals negative x squared, we know the graph like this. And still, we put the dot between these two arrows. It could be the graph like this. Now let's talk about n behavior. For x goes to negative infinity, means when x go to the very left side, the f of x that's going down, that's negative infinity. When you see the arrow going down, that's negative infinity. When x go to positive infinity, the graph going up, so f of x go to positive infinity. For this one, x go to negative infinity, the f of x is going up, so positive infinity. When x goes to positive infinity, f of x, let's go to negative infinity. Because the graph going down. For the pattern like y equals x squared, no matter x go to positive or negative infinity, the graph will both going up, so go to positive infinity. For the graph like y equals negative x squared, the graph both going down, so let's go to negative infinity, and here's negative infinity. Now let's go to some practice. Find the leading term and the end behavior of polynomial functions. We know for number 1, leading term is 3x to the 4th power. Positive leading coefficient and even exponents like x squared. So the graph will be like this. Therefore, we can figure out the end behavior. X goes to negative infinity. The f of x go to positive infinity. When x go to positive infinity, f of x still go to positive infinity. For number 2, leading term, that is negative 2x third power. The graph will be look like negative x. That means like this one. It has the same end behavior of negative x. Therefore, when x goes to negative infinity, f of x goes to positive infinity. When x go to positive infinity, the graph going down go to negative infinity. Let's do more practice, and we try to sketch the graph of a polynomial this time. First of all, find the leading term and the end behavior of a polynomial function. Then find the real zeros. After that, you need to use a sign diagram to sketch the graph of a polynomial. How to figure out the leading term if you are given this factoring form? We need to look at each factor. We find the leading term for each factor, then we do multiplication. We got 3 is a factor. X is a factor. X plus 5 is a factor, but this is to the 2nd power. That's why we got the x squared. Then x minus 4 is a factor. This is a leading term. You have to do 3rd power. So multiply by x to the 3rd power. Therefore, we got 3x to the 6th power. Graph like x squared. And behavior will be the same as x squared. Therefore, when x goes to negative infinity and a positive infinity, both going up, both go to positive infinity. Now let's figure out the real zeros. Still check each factor. Make sure each factor equals 0 to get a real zero. 3, definitely you cannot make 3 equal 0. So we ignore this 3. Then we go to this x. Yeah, we can get the x equal to 0. Now we go to x plus 5. So we make x plus 5 equal to 0. Then we go to x minus 4. X minus 4 equal to 0. So we got 3 zeros. X1 equal to 0. X2 equal to negative 5. X3 equal to 4. Now we go to number line. Label all these 3 zeros on the number line. we got this is -5, 0, here it's 4. Then choose a special number. Normally we chose 0, but since 0 is the roots, so now let's choose 1. I put in a box. Do not label on the number line. You only label the number on the number line is the roots or zeros. After you choose this special number, and then you need to plug in. So we got f of 1 equals, plug in this function now. 3 times 1 times 1 plus 5 squared times 1 minus 4 to the third power. We are looking for whether the value is positive or negative. So 3 is positive times 1 is positive. 1 plus 5 squared is positive. 1 minus 4 third power is negative. Therefore, it's a negative. After you get this is a negative, you will label the interval including this special number is a negative. Here it's negative. And how to label the sign for neighbor intervals? Here's the rule for sign diagrams. When a linear factor has an odd power, there is a change of a sign above that 0. When a linear factor has an even power, there is no sign change above that 0. We know -5, 0, and 4 are all zeros. For each 0, go back to check the factor. For this 0, we go back to check here. We got the x to the first power. That means there is an odd power. If it's an odd power, then you need to change the sign above that 0. That means for this 0, the sign of 2 neighbor interval are opposite. Therefore, we change the sign. This part is positive. Because of that is to the first power. If it's to the first power, we also call single factor. Single factor definitely change the sign. Now let's go to this -5. -5, we use this factor. This factor has even power. Look at this, even power. Even power, there's no sign change above this 0. That means we already know for -5, the right interval is positive. Then this must be positive because no sign change for even power. Now let's go to this 4. Check this factor. It's a third power. Third power, that's an odd number. According to the rule, this factor has an odd power, then there is a change of sign. Therefore, this is a positive. After we decide the sign for this number line, then you can sketch the graph of a polynomial. Think about this number line is like an x-axis. So negative, that means I will draw below this. And positive is above this. So connect the zeros first. Then if this is a positive, that means it's going up. Positive going up. So the green graph will be the graph of this polynomial. You could see that the end behavior is the same as x squared. Now, let's do the number 13. For this polynomial, we set up as an inequality less than or equal to 0. According to the angry face, we know that when you have a greater than or equal to or less than or equal to, when you have equal sign, this is a closed circle. So we put for each 0 is closed circle. Less than or equal to means negative. Therefore, only this part will be the solution. But don't forget these zeros, that's -5, still the solution. Therefore, the solution will be like this, 0 to 4 bracket. And also, don't forget this -5. This will be the solution to this inequality. Therefore, when you solve polynomial inequalities, you have to figure out 0 first. After you figure out this 0, then draw the number line. Get the special number, plug in to decide the sign for this interval including special number. Then using that sign-diagram rule to figure out the sign for each interval, then you can get the solution to this inequality. Let's do one more example. We have f of x equals -2x plus 1 squared times x minus 3. So the leading term, go back to each factor. We have negative sign first. The next factor, that's 2x plus 1. Leading term is 2x to second power. So we do 2x squared. Then the third factor, that's x. I multiply by x. Then we got -4x to the third power. The end behavior of this polynomial is the same as -x. For -x, we know like this. Therefore, when x goes to -infinity, the graph going up, let's go to positive infinity. When x go to positive infinity, your graph going down, so let's go to -infinity. Now let's talk about real zeros. Negative sign, definitely we cannot make this equal 0, but we can do 2x plus 1 equals 0. And also x minus 3 equals 0. So we got x1 equals -1/2. x2 equals 3. Now we label -1/2, 3. Then we choose a special number. Let's just choose 0. Then we plug in the special number. F of 0 equals -2 times 0 plus 1 squared. 0 minus 3. This is a negative sign going down. For this factor, that's a positive. This factor is negative, therefore we got the positive. So this interval is a positive. Then check for this -1/2. Where you get the -1/2 is from this factor. This factor has a even power. That means the neighbor interval has the same sign. It's a positive. Then go to this 3. 3, that's a single factor. This is to the first power. Therefore, the neighbor interval has the different sign. This is a negative. Then we can sketch the graph now. is a positive like this. And a positive here. This part is negative. Now let's go to number 16. Is we want to solve greater than 0 for this polynomial. First of all, we decide this is a happy face, greater than or less than, open circle and a dotted line. This is a number line, so open circle here, open circle here. Since we're looking for positive, therefore, it's this interval and also this interval. This part is negative infinity. Therefore, we can write down the solution from negative infinity to negative 1/2, open parentheses. Union set with negative 1/2 to 3, open parentheses. That's the solution to 16.